Thank you so much for joining us today. I really greatly appreciate the opportunity with ANSI and going over ASTM B10 on reactive and refractory metals and alloys. I'm partnered here with my B10 chair, Rick Porter, who is with Scanacone Incorporated. He's been with the committee since 2009, and he's been the B10 chair for 4 years right now. So it seems longer, Rick, but so today we're going to go over the macro overview of the committee and other particular details and give an opportunity for people that are online to ask questions and engage more specifically on these rare critical minerals. So next slide. So really quick, ASTM International, I know that some of these details were previously reviewed in F49, but it's always great to have a refresher. So ASTM International was founded in 1898. It is a globally recognized leader in the development and delivery of voluntary consensus standards. Today, we have about 13,000 plus ASTM standards, which are used around the world to improve product quality, enhance health and safety, strength, and market access and trade, and build consumer confidence, and most importantly, trust. Our leadership in international standards development is driven by the contributions of our members. There's more than 30,000 of the world's technical experts and business professionals representing 150 countries. Working in an open and transparent process and using ASTM's advanced IT infrastructure, our members create the test methods, specifications, guides, classifications, and our practices that support the industries and governments worldwide. So within ASTM International, as other SDOs, we welcome and encourage participation from around the world. Our open consensus process using advanced internet-based standards development tools ensures worldwide access for all interested individuals. The framework, I will go over those details on a macro overview at the end of the presentation. That's a little bit enhanced and streamlined. But ASTM International standards are the tools of customer satisfaction and competitiveness for companies across a wide range of markets. Through more than 140 plus technical standards writing committees that ASTM holds, we serve a broad range of industries between metals, construction, petroleum, and a newly formed committee on AI. ASTM standards are passports to a successful global training strategy. Our high quality market relevant standards developed in accordance with the guiding principles of the WTO organization, Annex 4. So that being said, today we'll go over the macro framework standards within B10, what is coming up in the pipeline, and how the standards are used from the ASTM committee on B10 on reactive and refractory metals and alloys. And those slides, again, will be led in conjunction with the B10 chair, Rick Porter, who has been a part of the B10 committee since 2009. Next slide.
Yeah, thanks, Jennifer, and thanks, Christine. So just kind of an overview of B10. As you can see, the main scope of B10 is dedicated to advancing specifications, knowledge, and encouraging research into reactive and refractory metals and their alloys. And the key metals are tantalum, niobium, hafnium, molybdenum, titanium, tungsten, vanadium, and zirconium. B10 has been around since 1965. There's 54 standards, 94 members, and 9 countries participate. The subcommittees, and we'll talk about some of the individual specs and standards on the next slide, are titanium, B1001, zirconium and hafnium, B1002, niobium, tantalum, and vanadium, B1003. Vanadium was a new addition to that, and we'll talk about those standards as new developments, as Jen had mentioned. And then also B1004 is molybdenum and tungsten. We have an administrative committee, which is the awards committee, that's also part of B10, as well as a symposium. The last one was in France in 2005. The next one will be in South Korea in 2025, and the next one will be in South Korea in 2028. And basically, they're presentations with a paper, and there's also poster sessions and an award given for the best paper at the symposium, and that's part of B10. Next, please. So the standards, so as I mentioned, titanium, zirconium, niobium, tantalum, vanadium, molybdenum, and tungsten. Most of the grades or alloys in B10 are titanium alloys. Probably the most volume, the most use are the titanium standards. There's about 40 grades of titanium, from commercially pure titanium to grades that have small additions of alloying elements, many that have some amount of ruthenium or palladium for enhanced corrosion resistance. 6.4 is ASTM grade 5. Everybody that knows titanium knows grade 5. There's some derivatives of grade 5 with palladium, with ruthenium. That's an alloy that I'll talk about when we talk about the applications. Niobium, tantalum, and vanadium, a handful of alloys or so, from pure to alloying additions, molybdenum and tungsten as well. There's a handful, 5 or 6 different alloys that are typically used with of those materials. Next slide. Who's involved with ASTM B10? Again, there's people from over 7 technical committees that have collaborated. Steel, stainless steel, non-ferrous metals and alloys, BO2, that was AO1. BO9 is metal powders and metal powder products. EO1, analytical chemistry, metals, ores, and related materials, concentrates. Many of our analytical specs come from EO1. So as far as the chemical analysis, inert gas fusion, combustion, ICP, OES, arc spark, those are all out of EO1. There is some harmonization with FO4 medical committee. Many of the medical standards have additional requirements, which could involve immersion ultrasonic testing and or even some microstructure requirements. F42 is additive manufacturing technologies, and then F47 is commercial space flight. So they have an interest in B10 committee as well. Okay, next slide. So some of the new materials are vanadium. So we have a work item that has been in process for the approximately the last year and a half to add vanadium and vanadium alloy ingots. There's 3 different alloys, a commercial grade, a pure grade, and a vanadium alloy that are being developed for inclusion in the new specification. The work item is currently in subcommittee. And there's a lot of interest in vanadium. Everybody hears about vanadium for redox batteries, but there's a lot of interest in vanadium for reactors. Many of the vanadium alloys, interestingly enough, they were made in the 60s and 70s and qualified and used, but they were done with the producer and purchaser, and there was never any type of ASTM specification developed. So right now we're working on those alloys and working on UNS numbers and working on getting them incorporated. And vanadium was also nice. It fit into B1003 with niobium and tantalum, so it wasn't its own committee. It makes sense to include it here to balance the interest. Molybdenum and tungsten, there's a new proposal, right? Not yet a work item, but I wanted to mention it for isotropic pure molybdenum, maybe with higher levels of carbon. So there's an interest in that alloy, which has better mechanical properties and but higher strength, but still good ductility. So that's a new alloy that was recently announced at committee week that hopefully will have a work item assigned sometime this summer prior to the fall committee meeting. Okay, go to the next slide, please. So the standards and the impact use, and I want to spend a little bit of time on this slide as opposed to the previous slide that listed all the material specifications, the purchasing specifications. So these alloys are all used in aerospace and defense. You can see that there's a lot of different applications there. There's also complementary ASM, uh, AMS rather, AMS material specifications and alloys that specify a lot of the aerospace grades in addition to specifications like ASTM B265 for grade 5 titanium, which is 6.4. And I mentioned that ASTM B265 grade 23, which is 6.4, 6 aluminum, 4 vanadium Eli, is a very frequently used, the extra low interstitial is what Eli stands for. It's a very much used form of 6.4. Defense, commercial applications for some examples are the Abrams tank, armor, titanium armor. The military has their own specification. They also couple that with B265 for the Abrams tank. So a lot of that is used there. Commercial applications, Apple, the iPhone, they use titanium and aluminum for the case, depending on the version that you have. So very widely used materials there. Nuclear energy, you saw, I guess the 551, the zirconium specifications. There's pure Zirc, there's Zirc 702, Zirc 705, Zircaloy 2, Zircaloy 4 have different specifications that govern the use of those alloys. So there's certainly many producers. There's a few producers in the United States and in France that regularly attend the committee meetings there. As far as chemical processing equipment, a lot of the alloys in our committee are used for chemical processing. Titanium, tantalum, niobium, zirconium. Just depends on the application. I'll say it this way: we have some of the most corrosion-resistant metallic materials in the world. If if you can't find it here, maybe you have to line it with glass, or in some cases, maybe a nickel alloy might have a niche. Electronics and some semiconductor manufacturing, tantalum, tungsten are used in capacitors, thin film coatings, sputtering targets, semiconductor fabrication equipment. Also, as we mentioned before, medical devices. So no surprise, but 6.4 titanium, along with zirconium in some instances, is used in hips and knees. And there's a lot of those products that are made, and typically 6.4 or there's some zirconium technologies as well. High temperature industrial applications, tungsten and molybdenum are typically used in furnace components, lighting, tooling, and they provide good thermal performance and material stability. A lot of people start with B10, and laboratories and manufacturers use the standards for testing, classifications, and quality assurance when developing new alloys or validating material performance. So they use a lot of the things that have been decided and determined or done in B10 as a basis for the alloys that they are developing. Next slide, please. Okay. Jennifer?
Thanks, Rick. I really appreciate it. Going through the specific details and how the B10 standards are being utilized within the industry. So a lot of the times with SDOs, there's always specific processes, especially if you're developing a specific standard with either SAE, ISO, ASTM. The process can be very convoluted, especially when you're developing drafts and where to go and how to actually complete those tasks. And I think this is a really great macro overview of the process. of what are the appropriate steps, also how to initiate, what are the actual requirements within those particular steps. So first things first, you want to identify that need. It's always very critical and important with any SDO. Um, is there enough support? Have the stakeholders been identified? Have you done your due diligence and ensuring that, we're not replicating information, uh, backtracking and doing our homework and making sure that we've identified those particular standards or stakeholders. And we want to communicate and collaborate that information. Next, you want to identify where that task would be held. What is that particular committee? Is it B10? Is it AO1? It's really important to know the specific designations within an SDO, and where to initiate that activity and where to communicate with. Typically with an ASTM, it starts with the staff manager so that they can help with those logistical process and provide the guidance that is needed. If there is a specific need, then obviously you want to take it to that appropriate committee and then present your case. What is that? Why are we developing this? Who are the stakeholders? What is the rationale? What type of standard, needs to be appropriately identified? And from there, we flesh out that draft. And we can form that task group. That's where that meat and bone gets developed within that particular subcommittee. And that may take many, many months and many trials, but you're obtaining feedback to ensure transparency and open participation and wanting the feedback as well. Once that has been appropriately fleshed out, then you want to proceed to step 3. You want to obtain authorization of the subcommittee chair or a motion made at a meeting, a committee week meeting. Once that draft is appropriately approved, then that item will go out to our balloting system. And anyone that is a member will receive, that is also a member, but a part of that subcommittee, will receive that email notification and have 30 days to review that particular document. They can download the document, they can save, they can also provide track changes. It's really important that members provide very clear instructive details so that we can improve the integrity of the document. I'm not going to get into the specific weeds of the requirements, but if that particular subcommittee ballot passes the subcommittee ballot and obtains 60% return required and 2/3 affirmative of the combined affirmative and negative votes, then it would proceed to step 5, which is main committee ballot and society review. And the main committee ballot is everyone that's on that particular committee, and they get to review and fine tune that particular document. Society is our public review. So as you can see down below, we also list concurrent ballot. So at times when a particular item has gone through quite a few iterations and fleshed out either at the task group level and or appropriately at the subcommittee level, and we're almost at that finish line, concurrent ballot can be utilized as a strategy. So concurrent ballot is when it means sub and main at the same time. So it reduces your time frame and duration of the balloting cycle. If no negatives are received throughout the particular process, then it would proceed to editorial, and then each committee within ASTM has assigned editor, and that editor will then provide the draft that was on the ballot, and then also the updated final draft to provide to the technical contact to ensure every detail has been updated per the ballot. From there, we would proceed to publication. Committee on Standards and Review at the bottom right-hand side, that is when particular items on ballot are receiving a negative, and we want to make sure that there's due process. So any type of negative is found not persuasive or not related, either on a ballot or at a meeting. Committee on Standards is that backhold. They want to make sure that did the committee follow due process and follow the regulations? So I hope this has been very beneficial. Obviously, within ASTM International, we do provide additional training on handling negatives, revising standards, and drafting new standards. But I really wanted to provide the full framework because this is really nice. This is extremely beneficial. I provide this to all my committee members because they just want the highlighted points of how do I initiate, what's required, what are my particular options, and what potentially that timeline would look like. Next slide. So how to actually join and participate. I did provide the link in the PowerPoint, also the QR code specifically for B10, which provides a macro overview of the scope that was reviewed, our current work items for standards that has been updated, as well as our future meetings. So our next date for B10 will be meeting at the November Committee Week. It is a hybrid event. Anyone is open to participate and attend the meetings. You don't have to be a member to come to the committee week meetings. If there's anyone that is interested in wanting to participate, our meetings are typically hybrid. Please email me. My contact information is at the end right there. But we encourage that collaboration. It gives an opportunity with everyone in the committee to review work items that are assigned to current standards or new developments, such as the vanadium standard that we had gone over, and make the appropriate revisions and prepare them for new ballots. A few other things I do want to point out, high-level resource, ASTM International has updated their ASTM training course. So it is a lot easier for members to participate. Also non-members to have a better understanding of the framework. I know that the previous slide that I provided is high level, and we can really get into details and spend considerable hours of going through each element. But also we did update our basic ASTM 101 training. So it's a visual aid that guides the end user, also our members, I should say, on the appropriate steps. So it's a little bit easier than consistently referring to the regulations. And I do strongly encourage both members and non-members to utilize. From there, I'd like to open the floor if there's any questions, especially pertaining to the committee. Thank you.